interact with these two and what kind of feeling it creates in the brain. So this he called it as simultaneous contrast. This is a translation of the sentence what he said. In the case where the eye see at the same time two contiguous colors, they will appear as dissimilar as possible, both in their optical composition and in the height of their tone. So what is tone, you will look in detail later. He also defined three situations. These are simultaneous contrast with nothing but hue between two colors placed side by side. Successive contrast, also known as negative after image. I am sure you must have seen some emails at least, which has a result in the negative after image. And mixed contrast, where two colors are seen, one immediately after the other, such that the after image of the first is mixed with the second. When we just talk in sentence about these contrasts, it is difficult to understand, I can imagine, because visualizing these concepts is very, very difficult. So what we have done is, we have developed some small way to understand it. I will make you that. The appearance of a light or object depends on what is around it. We were just telling that we reached here almost late night, not late night, around 9 o'clock. And while entering the hotel, the left side, that old building, it was lit very well. And we thought its color is something else in the night. But next day, in the daylight, when we saw, we could feel that it was a different color. It was totally a different color. The very same hotel, Taj Samudra, when we entered, that left side old building, no, very near to the main road, that old building, it looks totally different in color in the night because of the lighting. So we will try to understand a little bit on the lighting, what we have to use, why we need some kind of lighting. All this we will do today. So this effect is very important in life. We call it as metamerism. It's a special effect, very important to a designer. So two colors side by side interact with one another and change our perception accordingly. The effect of this interaction is called simultaneous contrast. Since we rarely see colors in isolation, in our life we see colors in an isolated situation very, very rare occasion. So always the background will play a big role. So simultaneous,
because what you see, it fools your eye. If this is red, maybe it is not red. It is only because of the molecules in the composition of the elements. So what you see here, I mean, I am not very colorful at the moment. It is more black and white, but that lady has a nice blue shirt. So actually it's not blue, it's just the composition of the material. What is the proof? These are two foils here. We call it polarization filters. So these polarization filters, they just permit the trespassing of a light of one specific ondulation, right? Ondulation. So now you can see there is something here, light is going through. Light is going through. Now, if I turn this, it's going to be black. So there is no light passing. If I turn it around, light is passing. Photographers, they know that phenomenon. They use these filters if they make photographs into windows. If you want to make a photograph into a window without reflecting your own image, then you need a polarization filter to filter out the reflecting wavelengths. So this is what we are doing here. It's a polarization filter, and by just turn it the direction of the filter of the lenses here, then you don't allow the passing of light. So what does that tell us? At the moment, nothing. This is a piece of plastic. It has no color, right? There's no color in it. It is totally neutral. If you use a polarization filter,